Hi friends, welcome to EAPCET Study Circle. In this video, I am going to discuss about electric current relevant theory for solving problems. So if you understand this theory, you can solve any kind of problem on these topics. If you are first time watching my channel, please subscribe to my channel and press the bell icon so that you will get the video notifications. Electricity is a form of energy. Electricity means it's a form of energy. The flow of electricity is called as electric current. In simple words, what we can say, electric current is nothing but a flow of electrons in a conductor. What is electric current? Electric current is nothing but a flow of electrons in a conductor. So as per the definition in academics, if you want to write, you can write this definition. Electric current is defined as the amount of charge flowing through a specific area per unit time. So in explanation you can see, for example, this is a conductor, this is a cross section of a conductor. You see, electric current is nothing but a amount of charge flowing through a cross section of a conductor. This is a cross sectional area, amount of charge passing through this cross section of a conductor in a unit time is called as electric current. I equal to charge by time. Again I am repeating, here specific area of cross section is same only. You see, electric current definition is amount of charge flowing this specific area per unit time is called as current. Amount of charge passing through this specific area per unit time is called as electric current. Okay. If 1 coulomb of charge is passing through this cross section of conductor in 1 second, we can say it is 1 ampere current is flowing. Okay. For example, if 2 coulomb of charge is flowing, for example in 3 seconds, what we can say? 2 coulomb of charge is flowing in 3 seconds, what we can say? How much current it is? It is Q by T, that is how much? This is 2 by T is 3. So 2 by 3 will get the answer. So 2 by 3 amperes. And here charge means electron or proton here. Generally we take electron as the charge particle here because electron is a negative charge particle and proton is a positive charge particle. And in any conductor, if we say the current is flowing in this left to right, if current is flowing in this left to right, we can say the electrons are flowing in right to left. Okay, this will be opposite to the electron direction. Okay, if electrons are flowing from right to left, we can say it is current is flowing from left to right, and protons direction and current direction will be same. The current direction is this one, so positive, that is proton direction is from left to right only. Simple problems will be given on this. They will give you the charge and they will give you time. Just simplify this, you will get the answer. The units of SI units of current is amperes, and the units for charge is coulombs, and time period is seconds. And if you simplify these two, and you will get the current value in amperes. And the units are coulomb per second or amperes. So in given question, if they give you in minutes, we need to convert into seconds and have to simplify. And for calculation of the average current, and this is the formula, I equals to NQ by T. If n particles each having a charge Q pass through a given cross sectional area in a time T, then average current I equal to NQ by T. Okay. So one charge particle is going, then we can say it is 1 Q by T. If 2 charge particles are passing through the cross section of a conductor, we can say it is a 2 Q by T. If 3 particles are going, that means 3 Q by T. Okay. So generally current formula is charge per unit time, but in this, if n particles, if number of particles are more, it will keep on increasing. Okay. And based on this also problems will be given. What is the number of particles, they will ask you. Okay. What are the number of particles, or we can say what are the number of electrons, they will ask you. Okay, for calculation of number of electrons also we need to use this formula, I equal to NQ by T. If f is the frequency of revolution in Hz of a particle and w is the angle of frequency in radian per second and v is the linear velocity of charge q, r is the radius of circular path, then average current associated with revolving charges. Average current associated with revolving charges I equals to q by t. So if they give you frequency, what is the formula we can use? I equal to, instead of 1 by t, you can write f as a frequency. You know that f is nothing but a 1 by time period. Just substitute here, you will get the fq. Okay. For many problems, they will give you frequency. They will give you frequency or revolutions per second. Okay. For calculation of the current, we need to use the I equal to fq. And if they give you in question, if they give you in radian per second, in some questions they will give you radian per second, then what you have to do, in place of frequency, we need to write w by 2 pi. Okay. For converting this into this radian per second into Hz, we are multiplying it 1 by 2 pi. Here frequency Hz is given, we need to convert into radian per second. What you have to write? W by 2 pi. Again I am repeating here, you see, if the frequency given in Hz, we can directly substitute here revolutions per second, or Hz if they give you, directly you can substitute here. And if they give you in radian per second, we need to multiply with 2 pi. We need to multiply with into 1 by 2 pi, so that it will convert into Hz. Don't forget this. If they give you in Hz, directly you can substitute in this formula. If they give you in radian per second, if they give you frequency in radian per second, we need to multiply with into 1 by 2 pi. Okay. Just simplify this, you will get this. Okay. W by 2 pi into q, or you can write it as this one. Okay. 2 pi r. And this formula I have written from here. And you see, in a hydrogen atom, electron moves in an orbit of radius r meters with a speed v meter per second, equivalent current. Current equal to f into E, and this frequency can be written as v by 2 pi r into E here. Okay. V by 2 pi r into E you will get. The same here I have written. Okay. Q is nothing but a charge of an electron. So E came here. So in some problems they will give you in a hydrogen atom. In hydrogen atom, they start with the hydrogen atom, and electrons moves in an orbit of radius will be given. And speed of that electron will be given. Radius will be given and speed of the electron will be given. Then we need to use the formula I equal to v by 2 pi r into E, that is charge of an electron. So just I have written here, same formula. And in some problems they will give you discharge tube or hydrogen tube. In any problem they will give you discharge tube or hydrogen tube. We need to use this formula. You see, N1 protons are moving from right to left in t seconds. Sorry, this should be left to right. And this should be right to left. Mistakenly I have written here. If N1 protons are moving from left to right in t seconds, for example, this is a discharge tube. You see, N1 protons are moving from left to right. N1 protons are moving from left to right in t seconds, and N2 electrons are moving from right to left. N2 electrons are moving from right to left. These are left to right moving, and these are right to left moving. Then this net current, the net current passing through this any cross section of the discharge tube is electric current in discharge tube is, what is that? I equals to N1 and N2 are in opposite direction. Okay. N1 and N2 opposite direction. So total, it becomes total N1 plus N2. Number of particles will be added up here into magnitude of charge of an electron by time period. Here this is the magnitude of charge of an electron or proton here. Okay. Here current direction will be in the direction of protons only. Okay. N1 protons are moving from left to right given. So left to right given. So current also will be in the proton direction only. So current direction will be left to right. So many problems will be given on this concept. Okay, only they will change you the numbers. You need to substitute here and they will ask you the direction of the current and direction of the protons. And next, drift velocity. When an electric field is applied in a conductor, a force acts on each electron in a direction opposite to that of the field. The electrons start moving in random motion. As a result, the electrons drift slowly in that direction. And in simple words, we can say the average velocity acquired by a free electron by an application of electric field is called as drift velocity. Again, I am repeating. The average velocity acquired by an free electron by an application of electric field is called as drift velocity. And drift velocity can be written as current density by number of electrons into charge of an electron. Drift velocity can be written as current density by number of electrons into charge of an electron. Okay, here current density can be written as I by A. Okay, current density can be written as current by area of cross section of conductor. So just substitute here. It becomes I by NAE. Okay, J means I by A. So we can write I by NAE. So drift velocity formula Vd equal to I by NAE. It will be very useful for solving many problems. Here I means current, N means number of electrons, A means area of cross section of conductor, E means charge of an electron. So if you substitute these values, you will get the drift velocity. In some problems, they will ask you average time taken by the electron. Average time taken by the electron they will ask you. For such kind of problems, we need to use T equal to L by Vd. The length of conductor by drift velocity of that electrons. Okay. Average time taken is T equal to L by Vd. Vd means you know that I by NAE and L means length of a conductor. Just substitute here, you will get the average time value. And regarding this, one more problem will be given. And equal current flowing. Okay, in a conductor, equal current is flowing and double the radius of the conductor. Okay, equal current is flowing but double the radius. Here radius is R1 equal to R. Here R2, radius is 2R. Okay, same current is flowing, double the radius. Problems will be given. For that, we need to use Vd, that is inversely proportional to A. Use this formula, you will get the answer for such kind of problems. The amount of work done in moving a positive charge from one point to another point is called as potential difference. See, what is the potential difference? The amount of work done in moving a positive charge from one point to another point. Okay, from this point to this point you are moving this. Okay, the amount of work done in moving a positive charge from one point to another point is called as potential difference, and potential difference you can represent as V equal to W by Q. W means work done. Okay, W means work done and Q means charge. Okay, in many problems they will give you the potential difference and charge. We need to calculate the work done. Okay, and they will give you two different voltages and we need to take a potential difference of that, we need to take a difference of that, and that we need to multiply with Q, then you will get the work done. Playlist video link I will give in the description. Please go through it. If you understand these concepts, all the problems you can solve it. Okay, if you understand these concepts or whatever concepts I have told here, 8 concept relevant formulas also I have explained. If you understand these 8 concepts, you can solve any kind of problems which I have explained in last 3 videos. You can solve any kind of problem. Okay, so thanks for watching this video. Please like this video and share this video with your friends, and don't forget to subscribe this channel for more videos. And one more thing, your friends or your friends' children may preparing for this JEE or NEET exam, so try to forward this video to their friends. Okay, thank you.